Hello everyone, welcome back to Savi tutorial on subject hydrology and irrigation engineering with the subject code 18CV63. In the previous class, we have discussed about the introduction part to the first module, that is hydrology. We are discussing the first part of the module 1. So, and today we are going to discuss the hydrological cycle, in that the Horton's representation and the engineering representation of hydrological cycle. So, as you see here, as you know, and already you have studied this hydrological cycle. So, coming to the definition of hydrological cycle, so hydrological cycle is the chain of process, so where the water changes from one form to another form and coming back to the same form. So, using different processes, so is called the hydrological cycle. Okay. So this is how the pictorial representation of hydrological cycle. So what the every time there is no proper start for this hydrological cycle, but always will assume the hydrological cycle start from the ocean because the ocean contains a large quantity of water. So we are going to assume the ocean is the start of the hydrological cycle, and the sun or the solar energy is the energy which drives the hydrological cycle. So we have various process or the components of hydrological cycle. The first is evaporation, and after that condensation, precipitation, and after that again infiltration, percolation, and transpiration will be there, runoff. So all these are the different components of a hydrological cycle. So let us just see. So as I have already told, a hydrological cycle is nothing but it is a chain of various processes. So where the water changes from one form and pass on to the another form and return back to the same form. Like water will changes from liquid form to a vapor and vapor to again liquid. Okay, that continuous process is called the hydrological cycle. So where water changes from liquid to vapor, vapor to liquid, and again or a solid, and again coming back to the same liquid form. That is the process continuous. It is a cyclic. Okay, so this hydrological cycle is also called as the water cycle. So where the water keeps on changes from one form to another form and return back to the same form. Okay, so it can also be defined as the circulation of water between ocean, atmosphere, and the land. As you see here in the figure, so it is between ocean, atmosphere, and the land. So we can say the change of water from. So it is the change of water between, or the process of water, so or the circulation of water between ocean, atmosphere, and land is called the hydrological cycle. Okay, so there are so many components of this hydrological cycle, as I have already showed in the picture. So evaporation, transpiration, condensation, precipitation, infiltration, and runoff, as you see here. So the very first is evaporation, condensation, okay, precipitation, and again runoff will be there, and infiltration. Again, if you go deeper, you'll be having percolation, so transpiration and evapotranspiration. So all these are the different components of hydrological cycle. So let us see. See, as I have already told, so we are going to say the hydrological cycle starts from the ocean. So because as ocean represents a very large quantity of water, so we're going to say hydrological cycle. So we'll start from ocean, as there is no start and end because it is a cyclic, it is a continuous. There is no start and end of the hydrological cycle, but usually we are going to assume it as ocean because it contains a vast amount of water. And the very first, the water will evaporate from the, as you see, I'll just see here. So the water will evaporate, that is the water changes from liquid state to a vapor state. So through the evaporation, so that is through the solar energy, so which is responsible for the evaporation process. And after that, so the water vapor will form into clouds, so where it will carry to the cooler environment, which will form, so through the condensation. Okay, so it will the pressure, the water pressure, so will get cooler, and after that the precipitation occurs. So that is again the change of water from vapor state to liquid state, and it will falls onto the ground, and we have various forms of precipitation. The precipitation occurs in terms of rain and snow. Okay, and we'll discuss later. Okay, coming to the precipitation in detail. Okay, so it will fall onto the ground, and some quantity of whatever the rain precipitation occurs will flow as a surface runoff. Okay, and some will infiltrated into the ground surface. Okay, and it will reach to the groundwater. Okay, so it will form a groundwater reservoir, and again, oh, if we go still further, it will percolate deeper, and below the ground surface it will flow, okay, as in groundwater flow or a base flow, what we can say. Ultimately it will reach back to the ocean. Okay, so that is where again the process repeats, like evaporation, condensation, precipitation, again infiltration, and like this the process repeats. So as I told, like water evaporates from the ocean surface and it will reach to the atmosphere in the vapor form, and it will undergo circulation. So depending upon whatever the wind velocity and depending on the atmosphere temperature, so the cooling of that water vapors will occur. That is the water vapor condenses, so which will resulting in the precipitation. So that the precipitation will be in the form of rainfall or a snow. Okay, and whatever the rainfall which falls, some will flow as a surface runoff, as you see here in this picture also. Some quantity of water will flow as an surface runoff, and the remaining quantity of water will get infiltrated into the soil surface or the ground surface. So where it will flow as a subsurface flow, and so it will, and after the infiltration, the remaining water molecule, so or the water content or the precipitation will percolate below, and it will reach the groundwater reservoir, and ultimately it will reach back to the ocean, so where it takes several years to reach the ocean, and again the process repeats. Okay, so that is what the hydrological cycle, that is how the process occurs. And the part of this infiltration will go down and reaches the groundwater reservoir, as I've already mentioned. Okay, and the part of water from that groundwater reservoir will flow laterally, so and so that is as an base flow and reaches to the ocean. As I told, it will reach ultimately to the ocean. Okay, and so whatever the precipitation which falls, some part of the precipitation will falls on the land surface, and it will return back to the atmosphere, and some part will fall onto the vegetation, where that will return to the atmosphere as an interception. So whatever the precipitation which falls onto the vegetation, okay, so that is called interception. Okay, and so as I've already told, we have various components of hydrological cycle: evaporation, condensation, precipitation, infiltration, runoff. So first we'll see the first component, that is evaporation. So what is evaporation, by the way? So evaporation is nothing but the loss of water or the change of water from a liquid form to the vapor form, or the loss of water in the atmosphere from water and land surface. Okay, so that is from the ocean or the whatever the moisture content which is present on the land surface. So due to the vapor pressure gradient that is between the evaporating surface and the air. So that is called evaporation. Simply we can say the change of water from liquid form to the vapor form, or the loss of water from liquid form, or whatever the water which is present on the ocean or the land surface. So due to the vapor pressure, difference in vapor pressure in the atmosphere is called evaporation. And so as I told, it is simple terms, we can say it is the change of water from liquid to gas. Okay, and basically solar radiation is the main energy which is driving the hydrological cycle. So for evaporation also, solar radiation is the principal energy. And here approximately 80% of the evaporation is from the ocean. So as ocean carries a large quantity of water, okay, So maximum percentage, that is 80% of the evaporation will occur from ocean, and remaining 20% is from like inland water and vegetation. And also, so this evaporation rate is affected mainly by the wind velocity. And the evaporation from soil surface basically depend on the depth of water table and type of the soil. Okay, so because if based on the type of soil, the moisture content which is present in the soil will vary. Okay, based on that, the evaporation will also vary. And the second component of the hydrological cycle is the transpiration. So what is transpiration? See, it is a loss of water from vegetation. So transpiration means, so it is the loss of water which is going to occur in the plants. Okay, so the loss of water from vegetation when there is a difference in the vapor pressure, that is vapor pressure in the air is less than that in the leaf cells. Okay, because as I have told, it is the loss of water from vegetation is called transpiration. So when there is a difference in vapor pressure between the air that is in the atmosphere and the leaf cells, so then the transpiration will occur. And the transpiration is nil when the relative humidity of air is 100%. Okay, when the humidity is 100%, so then the transpiration is nil. And also the amount of transpiration mainly depends on type and density and size of the plant. So type of the plant, density of plant, and size of the plant. So based on this, the amount of transpiration will vary. And the phytophytes, so that is a causes heavy loss of water due to the transpiration. Okay, while as xerophytes which have a shallow root system causes a minimal transpiration loss. See, these are the two kinds or the two types of plants, so where which will vary the transpiration value. Okay, so phreatotypes are the types of plants, so where which has the loss of water is more. So xerophytes are the type of plants where there is a less transpiration losses. And the third component is the condensation. See, it is a process by which water vapor changes into liquid form. It's water vapor changes into a water is nothing but liquid form. So water vapor condenses to form a dew, fog, and clouds. Okay, so it will condenses means cools. Condensation means it is nothing but cooling. Okay, so it will form into a dew, fog, or a cloud. So here it takes place due to the cooling of air molecules. And also as the water rises higher in the atmosphere, so it starts to cool and become a liquid again. So when the vapor molecules goes to higher altitude, so the atmospheric pressure is going to reduce, so which cools the water vapors, and that will become a liquid once again. And when that liquid so come while passing, so that liquid molecules, that cooler water vapors will be carried by the wind, and while carrying, so it will collide with other water vapors or the liquid, and that will fall onto the ground as a precipitation. And when large amount of water vapor condenses, okay, so it results in the formation of clouds. So the deposition of water molecules, when the large and large water vapor getting deposited in the atmosphere, it will condenses so to form a cloud. So when that particular clouds carried by the wind, so while carrying, so they may collide with each other, and that will fall as in rainfall. And the next component is a precipitation. So what happens when water vapor in the clouds gets too heavy? So that is, so when, for example, if you consider this is a clouds, when the more and more water vapors goes and deposited in the atmosphere, it will become heavy. Okay, so it will become heavy. So when it reaches a maximum limit, then that particular water falls back to the earth. Okay, that is called precipitation. And we have various forms of precipitation. It will occur as a drizzle, it will occur as a rain, it will occur as a snow and hail. Okay, and also the atmospheric pressure is a result of condensation of water vapor around the hygroscopic nuclei in the atmosphere, means where there is a lower or a cooler environment, so the atmospheric pressure precipitation is basically due to the condensation or cooling of water vapor. And this hydrological cycle so can be represented in different ways. So that is in a different diagrammatic form. So that is the majorly. So we have two representations. See the very first representation what I've showed. So this is actually a descriptive type of hydrological representation. Descriptive representation of hydrological cycle. So whereas this particular there are other two representation, that is Horton's qualitative representation and Horton's engineering representation. So if you see here, so the first one is the Horton's qualitative representation, which was proposed first time by the Robert Horton. Okay, so where he have prepared a special representation for this hydrological cycle. So if you see, so this one diagram shows the complete hydrological cycle. If you see here, the atmospheric moisture, so in transportation and storage, so it will form into clouds, and later, so the second component, that is the precipitation. So where precipitation has a different forms like rain, hail, sleet, snow, dew, and frost. So once the precipitation occurs, so it will, some of the precipitation so will be a surface deposition as of precipitation, that is it will reach the ground surface. Some of the quantity of precipitation will reach the ground surface, and some of the precipitation that is dew and frost evaporates while falling itself, and some of will intercepted and evaporate from the trees and vegetation, and some will be temporarily stored on surface, and some quantity of water will get infiltrate and it will reach the groundwater a reservoir, and from that the groundwater reservoir, it will reach again to the ocean, and in the turn it may reach to the streams also, rivers and streams, and so surface runoff, so some quantity will flow as in runoff. Okay, and some quantity will flow to the ponds, lakes, and streams which are present on the surface, and ultimately it will reach the ocean. Okay, so it will reach the ocean again. From the ocean, so evaporation will occur, and some of the water like may occur, may evaporate through the plants, that is as in transpiration. Okay, and ultimately, so reaches, all the water reaches to the ocean storage, and again from the ocean, again the process repeats. It will evaporate again, it will precipitation occur. So this pictorial representation is a qualitative representation of hydrological cycle, where you can will get a clear and complete picture of the Horton hydrological cycle. Okay, so the second representation is a Horton's engineering representation. So this is also quite simple representation of hydrological cycle. If you see, okay, so this is the ocean. So where from the ocean, so the evaporation occurs. So if you see this, this represents evaporation. So from the evaporation, it reaches atmosphere. Okay, so from the atmosphere, so the precipitation occurs. Okay, so if you see the precipitation, so will reach to the, will be as in snow and ice. Okay, so from the atmosphere directly fall to the land surface, or falls as in snow and ice pack. Okay, and some will fall on to the vegetation. Okay, so from the vegetation also directly the evaporation will occur, and also whatever the snow and ice pack. Okay, so that particular form of precipitation, if it evaporates and again reaches to the atmosphere, that is called sublimation. So without reaching the land surface, the evaporation is occurring. So that is through the snow and ice pack. So that is called sublimation. And again, okay, so from the snow and ice, it will melt and reaches the land surface. So, and once it reaches the land surface, some of them will flow as a surface runoff and reaches the streams and lakes. And again, from the land surface, it will infiltrate and reaches the soil surface. And again, in the soil, there will be a flow. So that is subsurface flow, which is called a interflow. Subsurface flow will occur. and also there will be interflow, that is from the rivers and lakes, so it can reach back to the soil surface, and again after the infiltration, again it will reach the groundwater reservoir or aquifers, so through a percolation. And also here, the whatever the flow of water through the groundwater, from the groundwater reservoir, that is called groundwater flow. Okay, and also uh, the flow from a groundwater reservoir back to the rivers and stream, okay, that is called a base flow. And also, so when if it reaches the soil again, so that is called capillary rise, means against the force of gravity, it is called a capillary rise. Okay, and ultimately all the water again reaches back to ocean again, and also the from the streams also the evaporation will occur. So again, the process repeats, like evaporation reaches to atmosphere, precipitation, and runoff, subsurface runoff, and infiltration, percolation. So this is how the engineering representation will look like for the hydrological cycle. Thank you. So today we have discussed hydrological cycle representation, different pictorial representation. So the next topic we can see in the next class. Thank you.